Good day, boys and girls. Welcome to the last lesson in this chapter. Wow, after all this time, we're finally wrapping up. Today, we are talking about, well, that's not the color I want. Comparing and ordering rational numbers. Yay, comparing and ordering rational numbers. Now, a rational number is any number that can be written as a fraction or decimal that is terminating or repeating. Okay, so any number that can be written as a fraction or a decimal that is terminating or repeating. So all the numbers we've been dealing with over the past couple days: mixed numbers, improper fractions, regular fractions, decimals, repeating decimals, whole numbers, all those kinds of things, those are classified as rational numbers. So today we're going to talk about comparing different types of rational numbers. All right, so let's say that I have some fractions here. Let's say I have 7/9 and 2/9. I want to say, all right, which one of these two is bigger? And in order to compare these, I'm going to use my greater than, less than, or equal to sign. Okay? I'm going to use these signs here to compare my values. And I want to say, all right, well, since I know that the denominators here are the same, this denominator and this denominator, since they are the same, I look at my numerators and I say, oh, which is bigger, 7 or 2? Well, we know that 7 is bigger, so that means that 7/9 is bigger. Okay, so the way it works for fractions, comparing fractions. All right, we can compare fractions when the denominator is the same. We compare the numerator. All right. So we can compare fractions when the denominator is the same. When the denominator is the same, we can compare. Okay, so that's the important thing we're looking for. We want to have similar denominators in order to compare our fractions. And then once we have similar denominators, we compare the numerator. And we say, all right, well, now that our denominators are the same, we just look at our top numbers and we say, which is bigger? Which of the two top numbers is bigger? And that's the number that is greater. So a way that would work is if I said, all right, well, I have 5/6 and 7/10. Well, those two are not the same denominator. 6 and 10 are different denominators. So in order for me to figure out which denominator that I want to use, I want to find the LCM of 6 and 10. We're going to find the least common multiple of 6 and 10. So remember, to do that, we find our prime factorization. 6 is 2 times 3, 10, 2 times 5. Circle my things in common. This becomes a 2, this becomes a 3, this becomes a 5. 2 times 3 is 6, 6 times 5 is 30. So my least common denominator here is 30. My least common multiple of these denominators is 30. That means if I want my fractions to have the same denominator, I want them both to somehow get to 30. I want to get from 6 to 30, and I want to get from 10 to 30 somehow. And so we need to figure out how that's going to work so I can get from my original denominators to my new denominators. So how can I get from 6 to 30? What am I going to do to get from 6 to 30? Well, 6 times 5 is 30, yeah. 6 times 5 is 30, so I'm going to take my 5 here. Remember what I said about equivalent fractions? You have to do the same thing to the top and bottom. So if I multiply the bottom times 5, I also need to multiply my top times 5. And what is 5 times 5? 25. So 25 thirtieths is the same as 5 sixths. They are equivalent fractions. All right, then I want to go over here and say, okay, well, how did I get from 10 to 30? Well, this one, I said 10 times 3 is 30. So I'm going to do the same thing to my numerator, times 3, and that is 21. And so now I have 25 thirtieths and 21 thirtieths. I have the same denominators here, right? I have two denominators that are 30. When my denominators are the same, what do? I compare the numerator. Yes, compare the numerator. I don't know why that wasn't doing what I wanted it to do. I compare the numerator, and my numerators here are 25 and 21. 25 is bigger than 21, which means that 25 thirtieths is bigger than 21 thirtieths, which means that 5 sixths is larger than 7 tenths. So going back to the original problem, 5 sixths is the bigger value. Wow, that was a lot of steps to get to the point where we can compare these fractions. And so the point is, the goal here is that we can start to see and make these changes quickly. Make the change between this fraction and this fraction quickly. And make the change between this fraction and this fraction quickly. And be able to find those equivalent fractions quickly. Okay, so that's the goal here. The goal of what we're trying to do is find equivalent fractions and find them quick. So we're going to try that again and say, all right, well, what if I had, let's say I have, what do I want to have? 5 sixths. Again, we'll do 5 sixths and 8 ninths. We want to figure out, all right, which is bigger, 5 sixths or 8 ninths? Okay, so first thing, we want to find the LCM of our denominators. Our denominators are 6 and 9. Remember, the least common multiple helps us to know what equivalent fractions we use so that our numbers work. Okay, so 6 is 2 times 3, 9, 3 times 3, group some 3's, I've got a 2, I've got a 3, I've got a 3. 2 times 3 is 6. 6 times 3 is 18. So I want to get my fractions to have denominators that are the same in 18. All right. So if I said 6 times what is 18? 6 times 3 is 18. So I'm going to do 5 times 3 and give me 15. So 5/6 equals 15/18. Because I times 3 times 3. Yes? And then we go, all right, well, 8/9 is equal to 1/18. I get from 9 to 18 by times in by 2. Do the same on top. 8 times 2 is 16. So this is 16/18. And now that my denominator is the same, I compare my top numbers, 15 and 16, and we know that 16 is bigger, which means 16 is bigger, which means 8/9 is larger than 5/6. And there is our answer. So getting those quick equivalent fractions is going to be super helpful for us. All right, so that is what we know about fractions. But fractions are not all that we do. We also do decimals, and we want to compare our decimals as well. And so we're going to say, all right, what if we have 0.81 and 0.84. 0.81 and 0.84. So when we have decimals that we're comparing, what we want to do is we want to stack them on top of each other. Line up our decimal points. 0.81, 0.84. All right, and we want to go through and say, let's compare all of the values from left to right. So we're going to start with zeros. Is there any comparison between my zeros here? No, they're the same number. There's no comparison. Are there any comparisons between my 8 and my 8? No, they're the same number. There's no comparison. Is there any comparison between my 1 and my 4? Yes, my 4 is larger. I have a larger 4, which means that since this digit is bigger here, this whole number is bigger. The whole number is bigger. Think about it if we were comparing just regular 81 and 84. Well, we would say, well, okay, 84 is bigger than 81 is. And so since we know 84 is bigger, it works the same with decimals. In order for this to work, we have to have the same number of place values, okay? Same number of place values. So if I said, what if I had 0.34 repeating and 0.342, which is bigger here? Well, again, I'm going to stack these on top of each other. I'm going to say, all right, well, one of mine is 0.34, and that's repeating, so I'm going to, actually, I won't do that yet. My other number is 0.342. Now, be careful that we're not saying that this top number is like 34 and this bottom number is like 342. That's not what we're saying, because we can't compare them unless they have the same number of place values. And so to give them the same number of place values, I need to continue this repeating the repeating decimal. Since the repeating decimal is 3, 4 repeating, that means it will end up looking like 0.34343434 forever and ever and ever. So to give this the same place value, I'm going to put my next digit here, which would be a 3, right? Because my next digit would be 0.34343434. And now, since these have the same number of place values, I can say, well, which is bigger, 343 or 342? We know 343 is bigger, which means that this is our bigger number. Okay, decimals takes a little bit of practice. Takes a little bit of understanding and making sure our place values are all where they need to be. That is one of the most important things we deal with when talking about decimals, is our place values. Okay? Our place values are very important when we talk about decimals. Let's try one more, and then I will let you all free. Let's say we have 3.822 compared to 3.819. All right. Which of these values do you believe is bigger? I'm going to let you solve this one out. You let me know as your answer. I will see you all tomorrow. Have a great rest of your day. Love you. Enjoy your day.